We're back with day 76. What we're going to talk about today is integrals of velocity. When we integrate velocity, there are some things that we really have to pay kind of close attention to in order to get the answer that we're looking for. Right? There are different things we can do with integrals of velocity that provide different answers to different questions. Okay, so I want to start with just a couple of definitions here. We're going to start with the basic, simple, definite integral of v of t dt. We know that integrating velocity, right? If velocity was measured in meters per second, we know that this integral is going to come out to be in the unit meters, right? So a lot of times people's intention is to say, oh yeah, it's our distance traveled, okay? But because velocity can be positive and negative, right? If we think about a graph of velocity, it could be above the x-axis or t-axis, it could be below the t-axis, right? And it's going to create different things. The integral from a to b of v of t dt, this always gives us the displacement of the object from t equals a to t equals b. Okay. Displacement is very different than distance traveled, or can be very different from distance traveled. Okay. For example, imagine starting at a point, walking 3 units to the right, turning around and walking 2 units back towards the left. Right? You would finish at spot number 1 then, right? So you start at 0, go 3 to the right, you're at 3, then you go 2 to the left, so you're back at point 1. Your total displacement then, I'll kind of annotate this. So you start at 0, you walk to spot 3 meters, and then you turn around and go back, and you finish at 1 meter. Your displacement then is 1 meter. You ended up 1 meter to the right of where you started. Your displacement here would be 1 meter. However, your total distance traveled in this scenario would be 5, because we traveled 3 to the right and 2 to the left. Your total distance traveled would be 5 meters, whereas your total displacement is only 1 meter. Okay? And again, that's your displacement. You ended up 1 meter to the right. Let's think of another scenario. Yeah. So you start at 3 meters. You walk 2 to the right, then you walk 4 to the left, and you finish at a position of 1 meter. Your total displacement would be -2. You displaced 2 to the left of where you started, right? Again, here, my displacement was 1. My distance was, what did I say, 5? Here, your displacement is -2. Your total distance traveled would be 1, 2, 3, 4, 5, 6. Your total distance would be 6. Total distance traveled is always going to be a positive number. Okay, displacement could be positive or negative, or 0. Okay, I heard somebody say once, if you are born and you die in the same exact hospital, your total displacement for your whole life was 0. It's kind of an interesting way to think about it. Okay, So just the straight up integral from a to b of v of t dt will always give you the total displacement. Okay? If we want total distance traveled, sorry, let me give you one more example. So you start at 2 meters, and you walk, and you finish at 3, 4, 5 meters. Your displacement, right? You displaced a total of 3, and your distance was a total of 3. As long as you don't change directions, your displacement and your distance traveled will be the same. But very rarely do they give you scenarios. I mean, it happens occasionally, but very rarely on the AP test do they give you scenarios where something doesn't change directions. Okay, so it is possible to have displacement and distance traveled the same. Okay, so what if I want to know my total distance traveled? Okay, here's what I'm going to show you. I'm going to show you one formula. I'll show you another in another day. So we want to eliminate all of the negative velocities, and we want to count the negative velocities as positive, but we also want to count the positive velocities as positive. Is there a function that whether you're positive or negative always makes you positive? Well, there is, and it's called the absolute value. So if I do the integral from a to b of the absolute value of velocity, notice the absolute values are around v of t. They are not around the whole integral. Doing it around the whole integral doesn't solve the problem. It has to simply be around the v of t function. This will give you total distance traveled. Okay. Good. Now, sometimes this comes up, this total distance traveled, comes up on the calculator section of the AP test. If it does, it's really nice, because then we just have to type that into our calculator. If it comes up on the no calculator section, it's going to be a little bit more troublesome. We'll take a look at how to do that probably in our next video. Okay, the last thing we need to know is, one of the things they'll ask you is the location of an object, right? What is its position at time t equals 5? Let me give you a sample problem for this and see how it ties into our previous video. Okay, so we have an object's velocity is modeled by v of t, okay? Now, on tests, they'll give you some function for that. For right now, we're just going to leave it v of t. I don't care what the function is, okay? At t equals 0, the position x is 4, okay? So at t equals 0, this object has a position of 4. What is the position at t equals 10? Okay. Now we can't solve this because I didn't give you a function for v of t, but I want us to write an expression for this. Okay. So here's what we know. V of t is our velocity, x of t is our position. Right now, we know that x of 0 equals 4 because of this given. What this is right here is our initial condition. So at the start of this whole thing, I'm at a position of 4, and I want to know what is my position at t equals 10. Well, again, you can think of this in a couple of different ways. If you think about it from the video, our previous video, we can figure out x of 10, right? We can figure out the position at x of 10 by doing initial condition plus our integral, right? Again, I'm looking for the position at t equals 10, so I want to know x of 10. what is x of 10? Well, again, position is the antiderivative of velocity. So I can solve this simply by saying 4 plus the integral from 0 to 10 of my velocity function. This will be, the answer to that integral will be the position at time t equals 10. Now let's think about it in terms of the definition I just gave you. The definite integral from 0 to 10 of v of t dt, what does that give you? Displacement or distance? Well, we don't see the absolute values, so we know that that means displacement. So that integral, 0 to 10 of v of t dt, gives you your total displacement. Let's say it's 5. Let's say the answer to just the integral part is 5. Well, that means my total displacement, I moved 5 to the right of where I started. That doesn't mean my position is 5. That means I'm 5 to the right of 4. What would that be? That would be at position 9. Okay, so that's it for today. We'll look at some of these velocity problems and stuff tomorrow in class, or sorry, Wednesday in class. So have a good day. Nice short video for you. Talk to you guys later. 2 chains. Bye.